The topic is reduction of order. So let's do this example. Given that y1 of x is equal e to the negative 3x is a solution of second derivative of y plus 6y prime plus 9y equals 0, use reduction of order to find the second solution. So let's follow the method. The method says always use y equal u times u of x times y1. So in other words, you want the y to be equal to u, but y1 is always going to be given. In this case, it's e negative 3x. And then 2, we need to try to find the u. If we find the u, we're almost done, by substituting it into the dE. So how do we substitute it into the dE? We need, of course, first derivative and then second derivative, and we plug the y in there. So y is equal ue negative 3x means first derivative would be, we need to use product rule because remember u is a function of x. So derivative of u times e negative 3x plus derivative of e negative 3x times u. So y prime is equal u prime e negative 3x. Derivative of e to the negative 3x is negative 3 e negative 3x. Should I write to u here? Let me write to u on the left side, and that would be negative 3e negative 3x. Right, now we need to find, so this is going to be first derivative. We're going to need that. We're also going to need y, and we're going to need second derivative. Now this means that y, second derivative of y will be equal, now again, product rule here, u prime prime is u second double prime times e negative 3x, I'm using product rule, plus derivative of e negative 3x, which is negative 3e negative 3x times u prime, I'm going to write u prime on this side, plus, again, derivative of u is u prime times negative 3e negative 3x, plus derivative of that, negative 3 times negative 3 will be 9e negative 3x, times u. Well, where do I write the root? Let me just write it here. It's okay. Now let me make this look a little bit better. This is saying second derivative of ue negative 3x minus 3 u prime e negative 3x minus 3 u prime e negative 3x plus 9 u e negative 3x. Let's see if we can add anything here. Yes, minus 3 and minus 3 is minus 6. So second derivative of y is equal u double prime e negative 3x minus 6u prime e negative 3x plus 9ue negative 3x. Now let's plug everything in there. So this says, let me rewrite it. Say y second derivative plus 6 first derivative plus 9y is equal 0. This means what? So second derivative is right there. So u double prime e negative 3x minus 6u prime e negative 3x plus 9ue negative 3x, and then plus 6y prime, see? Plus 6y prime right there. So plus 6y prime is right here. So u prime e negative 3x, plus or minus to minus 3 ue negative 3x plus 9 times y is right there, so 9ue negative 3x, and all this is supposed to be equal to 0. So something is weird here. Plus 6y prime plus 9, yep, everything is good. So we need to distribute the 6 first. Second derivative of ue negative 3x minus 6u prime e negative 3x minus 9ue negative 3x multiply by 6, distribute 6u prime e negative 3x minus 18ue negative 3x plus 9ue negative 3x is equal 0. Now so let's see if anything can be simplified. This would not be, so second derivative of u e negative 3x, u prime e, these two of them, it's minus 6 plus 6, actually they cancel, and then 9ue negative 3 minus 18, well actually they cancel because 9 plus 9 is 18, minus 18 is 0, so this is equal 0. Now divide by e negative 3x, this is going to give us second derivative of u is equal 0. Now here we always let, maybe I should write it here as a method, you always let w equal u prime. So if we do that, this means that w prime is equal 0, and remember u prime is equal w. This means that w is equal a constant, let's call it c1, but w is just second derivative of u. Now this means that u, by the way I got this by taking integral of c1, by integral of 0, this is how I got w is equal constant. The derivative is 0 means w is equal constant by taking integral. Now same thing here, this means that u is equal integral, this time not of 0, of c1 dx, which means u is equal c1x plus another constant, let's call it c2. Right? Now we go back, we know that now that we found the u, we know that y is equal to u times y1. So y would be equal to u times y1, which is equal c1x c2 plus c2, oops, times y1 is e negative 3x. Now let's distribute, this will be c1x e negative 3x plus c2e negative 3x. We're almost done. We want a solution that's independent to y1. So we can't use e to the negative 3x, so we have to use this term. So basically we let c1 equal 1. So let c1 equal 1. Oops. Therefore y2 will be equal x e negative 3x, and you're done. So the solution will be x e negative 3x, and that's it.